Okay, now this problem, again, we're trying to find the infinite limit, and the first thing we probably want to do is to factor everything out. And so let's rewrite it. So I'm going to have the limit as x approaches 2 from the left. Here on top I can factor out an x, and I would have an x minus 2 left over. On bottom, this factors out into x minus 2 and x minus 2. Okay, now notice that if I plug in 2, on the bottom I would have 0, and on the top I would also have 0. And so this is a indeterminate form. And so what this means basically is that we have to do some algebraic manipulation to see what's going on. And so notice here that the x minus 2's are going to cancel. And if I rewrite it, I would have the limit as x approaches 2 from the left of x over x minus 2. And now notice that this is a rational function, and this is going to have a vertical asymptote at 2. So we're going to have an infinite limit here. Okay, so why don't we, since we're going from the left, we're going to plug in a number that's close to 2 from the left. So how about 1.9? And so let's plug that in to see what the sign is. And so if I do that, I would get 1.9 over 1.9 minus 2, that's negative 0.1, and this is a negative number. So that means this guy is going to negative infinity. Okay, so in this problem we're going to try to find the limit as x approaches negative 4. And well, the first thing we do is we try plugging in the value, but it's a lot easier to plug it in if everything's factored. So let's try doing that first. So let me rewrite it. So the limit as x approaches negative 4, and I'll factor the numerator. The numerator factors into x plus 1 and x plus 4, and the denominator factors into x plus 4, x minus 1. Okay, now notice that if you plug in negative 4, on the numerator you would get, here you would get 0. Why don't we write it out? So we're going to plug in negative 4. Negative 4, negative 4, negative 4, and negative 4. Okay, so what we would get is negative 3 times 0 over 0 times negative 5. And this is an indeterminate form, 0 over 0. So what that means basically is that we have to do more work. Now notice here that if we cancel out the x plus 4's, we get a function that's now continuous at negative 4. And so this allows us to substitute the value. So let me rewrite it. What's left over? Now if I plug in negative 4, I would get a negative 3 over negative 5, which is 3 over 5. And that's it. Okay, so to find this limit, remember the first thing you do is try to plug in the value. So if I plug in 1, I would get 0 over 0, and this guy is an indeterminate form. Okay, so what this means is that I should try doing some algebra trickery. So let me rewrite it. So we have the limit as x approaches 1. Now on top I have a difference of cubes, so I should remember how to factor that. That factors into x minus 1 times x squared plus x plus 1. And on the bottom I have a difference of squares, so this is simply x minus 1 times x plus 1. Okay, now notice that the x minus 1's can cancel, and now if I plug in 1, what I get is that the limit as x approaches 1 of this function, now that it's continuous, I would get that this is equal to, on top I would have 3 over 2. That's it. Okay, so in this limit problem, we're going to do our usual. If we try plugging in the number 4 on top, we would get 4 plus 2 is 6. 6 squared is 36, minus 9 times 4 is 36. So on the numerator I would have 0, and the bottom I would have 0 as well. And this is an indeterminate form, which means that I have to do more work, basically. Okay, so then in this case, well, it looks to me like this top is quite funny. Why don't we try, since it doesn't look like anything's factorable right off the bat, why don't we try expanding this binomial that's being squared. And so if I square that guy, I would get x squared plus 4x plus 4 minus 9x over x minus 4. Okay, so I'll combine like terms. So if I combine those two, I would get that this is equal to the limit as x approaches 4 of x squared minus 5x plus 4 over x minus 4. And so then we can try factoring this guy. Well, let's see here. X squared minus 5x plus 4, well, that looks quite factorable, into x minus 4 and x minus 1. And notice that, lo and behold, the x minus 4's are going to cancel, and if I now plug in the value of 4, I get that this guy is equal to 4 minus 1, which is 3. So the limit as x approaches 4 of that original function is actually 3.